Hey guys, if you clicked on this video, it's probably because you're planning to take the December 2025 SAT. Well, you're in the right place because we're going to be reviewing a couple problems that you potentially could see in the math portion of the digital SAT coming out December 2025. Before we get started, just to note, we have a playlist that's linked here where you can get freebie problems and review different types of problems that you potentially could see on your exam. Or if you're planning to get more practice for a future SAT, make sure to check out that playlist for those videos. And if you haven't done so, make sure to hit that subscribe button because we have more videos coming out in the future. And lastly, before we get started, please note the disclaimer listed below. Now let's get started. So for the November SAT, there has been a shift in the type of problems that you have seen if you have heard anything about the November SAT, and we predict this will follow throughout the new year. And that's this idea that there is less of a focus on types of problems related to algebra and instead problems related more to geometry, specifically conceptual problems like postulates, like this problem that you see on your screen here. So, for example, they tell you that there is a triangle and they don't give you the shape of the triangle. You have to draw it out yourself. And that's done on purpose. And they let you know that angle A is A, angle B is B, and they let you know that angle C is equivalent to 42 degrees. You are told that you have to find which one is not needed to find A and B. So there are going to be three that are equivalent to find A and B, and one that is not. So for triangle A, B, and C, we know that the sum of all of these sides has to equal 180 degrees. So A plus B plus our C, which we now know is equivalent to 42, equals 180 degrees. Bringing 42 to the other side will give you 138. You could type that into Desmos by subtracting both sides by 42. And A plus B will give you 180 minus 42, which is 138. So we know that these two angles now equals 138. Now, knowing this information, we have to postulate that we can get to those answers with these equations. So let's first start out with A, reviewing A. I'm going to use this color here, and I'm going to type in A here so you can see. We know that 42 minus A minus B has to give us, we're going to call it another variable k. Now we have to rearrange this so we can say that negative a minus b equals k minus 42 because we bring it over to the other side. Then I go ahead and turn everything positive. So that means multiplying this whole equation by -1. And the reason why I'm doing this is because I want to use my scenarios, these two equations, to try to get it as close as possible back to that original point. So we have A plus B equal K plus 42. And is going to be negative k. So I forgot to say that that's going to be because if I distribute the -1, it's positive a plus b equals negative k plus 42. Or if you want to rearrange it as well, you could say 42 minus k. For this to match up to our equation, we have to go ahead and now say that 138, because we know a plus b equals 138 from here. I'm going to go ahead and say that a plus b equals 138, 42 minus k, and k gives us -96. So by conclusion, we can have this equation to say that we can solve for it in some way. So because we have negative 96, we can go ahead and plug that back into this top part right here, the original equation, to say 42 minus A minus B equals our new value of negative 96. Bring minus 42 to both sides. When I go ahead and do that, I'm going to go ahead and erase to give myself space here. And knowing that I can plug that into Desmos, I can go ahead and say negative A minus B is the same thing as negative 96 minus 42, which is negative 138. Because these are all negatives, I could just boop, make them all positive, assuming that I multiplied everything by negative 1. And now we get back to our original equation, A plus B equals 138. So A works in this scenario. So A is what is needed. That's fine. Now let's go over to B. To work with B, I'm going to do the same thing again, but this time you notice it's negative 2A minus negative 2B. So I'm going ahead and saying 42 minus 2A minus 2B is equal to K. I'm going to go ahead and now I'm going to say how do I rearrange this in the best way possible? I'm going to bring my 42 over to the other side because I want A and B to be on the one side just like before. So negative 2A minus 2B is going to be the same thing as K minus 42 because I brought that 42 over. Knowing this, I want to get back to A plus B. This is my goal, to get back to here. So I'm going to go ahead and take out my negative 2. And that's going to leave me with A plus B inside the parentheses equals K minus 42. Divide both sides by negative 2. And then what ends up happening when I go ahead to match it up, if I go ahead and subtract these, I get the idea of negative 42 divided by 2. But, so I'm going to have A plus B equals, now I'm going to flip it over because I have these two negatives. I'm going to make this 42 minus K divided by 2. Now you notice that I flipped the symbols by multiply everything by negative 1, and that's how I got here. Now I know the value of A and B is equivalent to 138. And how I know that is I'm getting it from up here. So I'm just going ahead and replacing it. I'm going to go ahead and cross multiply. When I do that, I get 138 times 2. If you plug that into Desmos, that's going to be 276 equals 42 minus K. Now I'm going to bring 42 over to both sides. So let me go ahead and say that I'm going to go ahead and subtract 42, and negative K gives you 276 minus 42 is going to give you positive 234. I want to shift from negative to positive, so I'm going to multiply both sides by negative 1, so it's going to be positive negative 234. So in conclusion, I'm saying that K equals negative 234. And remember, my original equation was this. So I can plug that back into here. When I go ahead and do so and I bring 42 over and divide, I will end up getting the idea that it's equivalent to 138 if it's proper. So what I mean by that is I have 42 minus 2a minus 2b equals negative 234 negative 2a minus 2b. Bring that 42 over, so minus 42 minus 42. This is going to give you negative 276. Divide everything by 2. Divide everything by 2. When I go ahead and do that, I get negative a minus b equals negative 138. Now remember, it has to be plus a plus b equals 138. So I'm multiplying everything by negative 1 plus a, and that gives me 138. So b also works as well. Because I'm running out of space here to check C and D, I'm going to clear my screen a little bit. So let's go ahead and erase b here because we already checked that and we checked a because we still need to check for C and D. And this, as you can see, is a very conceptual problem that takes some time, even though I take some shortcuts when doing so. So just be aware of that this is considered, I think, a difficult problem based on the timing and the concepts that you need to know. Now I'm going to take this equation and set it equal to k. So I have 42. Let me go ahead and erase so you can see the whole equation. We have 42 minus 2a minus b. This again equals k. Now I'm going to bring 42 over because remember, I want to get to a plus b equals 138. So bringing the 42 over gives you negative 2a minus b equals k minus 42. Multiplying everything with negative 1 is going to switch all the sides, so signs, so 2a plus b equals negative k plus 42. And just like before, I could flip this around, so I could say 42 minus k as well, just to make it easier. And the reason why I'm doing this is because I want to get a and b by itself. Now, we know that we have two systems of equations here. So we can plug this into Desmos. So essentially, what we could say is a plus b equals 138 as our first equation. And we can go ahead and say from this expression that we have it set equal to 42 because that's the same thing as the equation. So you can go ahead and have this first equation and then 2a plus b. Remember, this is all equal to 42. We know that the equation, you could plug this in, but we can't have multiple variables in Desmos. So just be aware of that when you are reviewing. So I'm going to populate this into Desmos. So you have 2a plus b, and I'm going to show my screen in just a second. 2a plus b equals 42. And then I have my second equation, which is 2a plus b equals 42. And if I go ahead and take a look at it, then it should be the same, or it should be able to subtract or solve. So we can go ahead and plug it into Desmos if you know how to do that. However, I'm going to show in the long form way just so you could see what I'm talking about here when you plug one into the other. So we have the first equation and we have the second equation, which is 2a plus b equals 42. And then remember we have the first one, which is A plus B equals 138. In this case, you can you could subtract, get rid of the B's, and then this is just quicker. You have A equals what we have 138 subtracted from 42, which is going to give you 234. If you go ahead and solve that way for A. So if we have, let me just double check here, 138 subtracted from 42 is going to give you, sorry, negative, not 132, negative 96. So you have negative 96 for A. So we didn't really need Desmos for this. It could have been easily checkable that we have negative 96. Now I can go ahead and plug that into my equation. So I have negative 96 plus B 96 plus B equals 138. Add 96 to both sides, and therefore B equals 138, or 234, plugging into Desmos. So that's going to be B equals 234. So if I check the values of negative 96 plus 234, plugging it into the calculator, that's when I get 138. So we know that C is correct. I know that was a little bit messy because I had to figure out whether or not I wanted to use Desmos or if it would be quicker just to solve it manually. And in real time, I just solved it manually with systems of equations. And then I double checked to see that A and B were going to equal 138, and that's what I got. So in this case, this is okay for C. Now I'm going to go ahead and try for D. Now, because I'm pressed for time and I've checked all these, technically, if I was taking the exam or the test, I would just go ahead and select D because I've checked the other ones. But I understand that this could be one that you want to double check. So let's just go ahead and try to solve with that going forward. So we know that this is equal to K, just like before. And I'm going to bring 42 to the other side. So you have 2A plus B, because I want A and B by itself, is going to give you K minus 42. Now we cannot simply rearrange to get A and B to 138. It just doesn't work. How I could do that, let's just see here if I have this value here. I could try to divide everything by 2, and if I do that, I could say, or yeah, if I divide everything by 2, I would have A plus 1/2 B equals K minus 20. And so already my value is getting smaller. It's not getting to the values that we had before. So I don't want to waste any more time. And so because of that, I know that it's going to get worse. And so because of this, I know D is not going to work. Remember, the other values would get to 96 or get to something around a value that was feasible that you could rearrange. So we would have something like a nine, like a in the previous choices, we had negative 96. If you remember in A, and because of that, I know it's not going to lead to the correct answer. So that's why I'm going to select D as my answer choice as being the one that's incorrect or the correct answer for this problem. I know this problem was very difficult. This was based off of a previous problem that was found to be difficult. And the reason why it was difficult was because you had to go through all the answer choices. In a type of problem like this where you get a double negative and not, some friendly tips is start off with A, try to go to C and then try D because this is a type of problem where they want you to try each one, A, B, C, D. And the problem is if you try ABC, you're going to be wasting a lot of time. So some students just try with the answer choice C, and if it's too low or too high, then they choose it. But this would be a problem where we know that we're going to have to try all of them. So I would try A and C and then go to D. And knowing how I worked A and C, I would know that D doesn't follow the same pattern. And therefore, by process of elimination, I would lean towards D, especially if I only have a couple of minutes left in solving this problem. That's the first thing. And second thing is when they give you a problem where they ask you to check all the answers, the majority of the time, the incorrect answer, not always, is D because they're thinking that you're going to go A, B, C, and go through every single one, therefore wasting time. So just be aware of that when you are solving problems like this. Hope that helps. Let's try to tackle this problem. If you want to, please pause the video to take a moment and review the following problem and then unpause once completed. Okay, so we're going to review this problem with a couple of things in mind. In the October and November SAT, there were several reports that indicated that there were problems related to a shape either touching another shape or a shape touching a line or a ray or tangent related problems, but they never actually gave you the shape. And you were left to figure out what was going on. So first, let's try to dissect the wording of this problem. It says a circle is inscribed inside a square. So firstly, what they're saying is that there is a square and that square has a circle. I'm going to try my best to draw this circle. This is not a great circle. Let's try this circle here. And maybe if I draw the square around it, you can see what I'm talking about. So what is happening is you have a circle that I want you to imagine that it's touching in all of these points, like here, 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 and here. I couldn't get it perfectly, but basically there's a circle that is inside a square and it's touching at 4 points, and they're asking you for the area of this square. So they're asking basically for that final area of the square, noting the equation of the circle. So I want you to note that when you're reviewing. Now let's go back to the problem itself and note that we can figure out based on the formula, we can figure out either the radius, which is going to be half of one of the sides, or we can find the diameter, which is the full side. So remember, let's start off with what they're looking for. They're asking for the area of a square. So that formula, area of the square, you want to either look it up or you can go ahead and use the formula sheet and you'll see that it says area equals side squared or length times width. Both are going to be the same. And I have to figure out one of the sides. The side is technically the diameter. So the full side is going to be the diameter because if I take the full end to end, remember this is touching, this is going to be the diameter, which means half of it is going to be the radius. So that means that I have to take a look at the circle equation that is given and convert it into the circle form to then try to figure out what my radius is. So let's start off with the equation. And let's tackle trying to break this down. Luckily, they have the X's in one spot and the Y's in one spot, so I can go ahead and remove the highest coefficient. In this case, I can go ahead and remove a 4 here. Now, Remember what the formula of a circle is. I want to preface this by if I had a formula of a circle, I'm going to put that here. This will not be on your formula sheet. You will be expected to memorize this. This is one of those, hey, you should know this by heart. And a lot of times students think that they could plug this into Desmos and somehow you could figure out the sides, which is great, but there is a tendency for these problems to not be able to utilize Desmos because they want to know that you have that understanding of the circle formula, which is this: x minus h squared plus y minus k squared equals r squared. Well, by the way, the r is your radius and h comma k is going to be your center. So just keep that in mind in case we need that in the future. I don't think reviewing the problem right now that we need it, so I just wanted to provide you that information because you might need it for a different type of problem that you might see in the future. Now going back to the equation here, I'm going to extract a 4, and the reason why I showed the equation is you notice that right now I'm not going to take out an x squared. I'm going to leave it in, or the x in here. I'm going to keep that out or in, I should say. So in other words, I'm taking out just the 4. I have x squared plus 6x. And I'm going to do the same with the y's. So I am going to take out the highest, which is a 4, leaving by y squared minus 4y and plus 15. Note this is all going to equal 0, right? So now for the x squared minus the x squared plus 6x here, I'm going to take half of the coefficient because I'm going to use a process called completing the squares. So to complete the squares, this is another process that you should know for the digital SAT. It is not something you can plug into Desmos and solve. And once again, there is an incentive to try to provide problems that you're not going to be able to utilize Desmos as much. So let's take x squared plus 6x, and to complete this square, what we need to do is take the coefficient of half of this 6. So you take x squared plus 6x, you take the number in front of the x and you divide it by 2. So 6 divided by 2 is going to give you 3. And then to complete this square, we have to square this. So that's going to be 9. So the process is to take not what's attached to the x squared, but take the number in front of the exponent that is 1. So x to the first power, take that number, that's 6, divided by 2, and then square it. Now that we have that, we're going to add that back in. We're going to do the same for this value here and complete the square. So I'm going to go ahead and do that for this. Remember, it's -4 here, so I have -4, right? Divided by what? 2. And then I'm going to square this whole thing just as a fast process. And when I go ahead and do that, I end up getting -2 over 2. And then -2 over 2 is just going to be -2 square, -4 over 2, I should say, is -2. Square it, and then that gives you 4. So in other words, I'm getting -2 squared, and that gives you 4. Okay, so as you can see in real time, I am following my own errors. So I have my 2 completing the squares. I have my 9 and my 4. So now I'm going to add these back into the equation, into their perspective parentheses as completing the square. And whatever I do to the left side, I have to do to the right side. And I'll explain that in just a second. So I'm going to use a different color here and go back to my orange. 4x squared plus 6x. I'm just going ahead and bringing everything over here, adding also my square, which is plus 9 that we solved here, minus 36. The reason why I got 36 is if you take 6 squared, that's going to be 36, right? And so whatever I have to do to the left side, I have to do to the right side. And if I go ahead and I'm squaring, completing the squares, I have to subtract because I added it to the other side. So I have to do the same to the left side. So same thing if I go ahead and take a look at 4 squared, that's going to give me 16. Okay, so whatever I do the left side, so technically we're subtracting it over to the other side, so subtracting 36. Then I go ahead and take, because I had 6 in front of this, see this 6 here? So I had 6 squared equals 36. I had the 4, the negative 4, but we know that negative 4, positive 4, it doesn't matter. It gives you a positive value. And then I'm subtracting it because this is all equal to 0. I have to bring it over to the other side. Whatever I do to the right side, I have to do to the left side. And then I have to go ahead and complete that as well. To go ahead and complete. So what I mean by that is I brought over the 36. I'm going to do the same for the other one. So 4 parentheses y squared minus 4y plus 4. That's my 4 parentheses. Going ahead and minus 16 plus, remember, I had that 15 in that original equation, so plus 15. And this is all going to equal 0, right? So now we have to go ahead and simplify this as much as possible. We can go ahead and take our numbers, our whole numbers, so our negative 36 and our negative 16 and our positive 15, and we can go ahead and simplify this further. So if you plug this into Desmos, negative 16, negative 36 minus 16 plus 15, you can simplify that, and that should give you, do you remember? It's negative 37. So I have negative 37. So I've simplified that even further. I can go ahead and take this and simplify this and simplify this by factoring. And this is the same thing as saying 4x plus 3 squared plus 4. Now I have to tackle this one right here. So this is going to be y, because it's negative, minus 2 squared minus the 37 equals 0. Knowing this information, I'm going to go ahead and bring the 37 over to this side and also divide both sides by 4. So bringing that over means that I have 37 over 4 because I went ahead and divided these two, and then I just have these two left over. So I have x plus 3 squared plus y minus 2 squared equals 37 divided by 4. Now we have figured out what our radius is, which is 37 divided by 4 squared. Remember, we're getting it back to this form. So we basically said x minus h squared plus y minus k squared equals 37 minus 4, 37 divided by 4. So we're basically saying r squared equals 37 divided by 4. So we have to take the square root of both of these, giving us the final radius. So that's 37 square root divided by 2. Because I want to understand that this is my radius and I need to find the area of this square, which requires me to have the full length of the side, the diameter has to be double this value because remember, the radius is 37 divided by 2. Because of this, I want to double it, so it's 2 times third square root of 37 divided by 2. Going ahead and letting us know that the diameter is square root of 37. So the side, the length from here to here is going to be square root of 37. So I'm going to use a different color here. And I'm going to erase some of the things that we have listed here. Because now we figured out our full diameter. So you can now see what the shape looks like. So we have the radius and the diameter. The diameter, or the full length of this side, we said is the square root of 37. Now knowing that, we could plug that into the formula, which we said is side squared. So we can go ahead and take the square root of 37 squared. You can eliminate the square roots because they eliminate each other. So our area is just 37. So that's your final answer. It seems like a very convoluted problem, which it is, but you need to understand a couple of things in this type of problem. One, you have two different shapes, a square and an area of a square. And so you have the formula with that square, and then you have a different formula, and you have the concept of completing the squares. So this problem teaches you several concepts. One, completing the squares, which is technically a mathematically algebraic based or advanced math problem. Then we have completing the squares utilized with shapes. So this is geometry and your understanding of those formulas. So you need to know completing the squares. You need to know the formula of a circle. You need to know what inscribed meant. And you need to know that you have to plug it back into the area of a square. So make sure that you tackle problems just like this, because this goes back to the concept of you're going to have multiple different concepts being tested in one problem. So it's a big time adjuster. So knowing that you're going to have a problem like this would be something I would leave towards the tail end, knowing that this will take a good 5 minutes to tackle and leave less time for the easier problems. And so this is a concept not of can I complete this as fast as possible, but do I know when to complete this to get the correct points necessary to pass? Take a moment and pause this video to try to attempt to do this problem yourself, making sure that you note that each of these values are exponents. So this one, this one, this one, this one. Make sure to pause the video and then unpause once completed. Okay, let's try to tackle this problem together. They let you know that there's a percentage increase of 240%. So that's the increase. And this is for every increase in temperature of 1 over 4 degrees Celsius. They want to know the initial population of P. Noting that we have a 240% increase, the original amount is going to be 100%, because we're starting out at that original amount, and then we went ahead and increased by 240%. Percentage problems are pretty big, and convoluted percentage problems are becoming bigger in the new digital SAT 2025 into 2026. And they usually start out with this idea that there's a over 100% increase. So you assume that you already added in that 100, which you did not. So this technically would be 340% increase. Or if you were to convert that into decimal point, 2 places to the left would give you 3.4 times the original. So we're saying that for every 1 over 4 degree increase, the population multiplied by 3.4. So if we have the number of intervals, we can say that the initial interval is t. And then we are increasing by 1 over 4. So that is 1 over 4. We can go ahead and divide this together. And when we go ahead and do that, you'll end up getting 4t. So technically, we are starting out with our original population. We are increasing by 3.4 every time. And then we are interval by 4t. So the best answer here that it aligns with is answer choice A. Noting that P is the initial population, 3.4 is our growth factor, and 4t are the number of intervals. So in this case, you need to understand that 240% increase means that you're multiplying by your original 100. Don't get fooled when they give you a percentage over 100%. We're still growing by that initial percentage. Also, note that we are converting intervals. So growth rate occurs 1 over whatever unit. So in this case, it's a fourth. So be sure to understand it's 1 over whatever that degrees Celsius is, or whatever that growth increases by. Do not make the same mistake when you are initially thinking that it's just starting out at 100 and therefore it's 240. And that incorrect answer choice was in C and in D. And also think of it as t over whatever your value is instead of the other way around, because that could cause multiplication problems or division problems. And don't forget that your initial population is P.
Appreciate you riding along for our cosmic journey. If today's mission brought you the knowledge that slaps, make sure to hit that like button to boost that signal. Subscribe if you're locked in for our next watch. And don't miss the link tree. It's got all the goods for AP Bio, PSAT Math, and SAT Math. Before I sign out, make sure you're all in one orbit and diving in. Killing out. Till next time.